Hello everyone. This presentation was prepared as a part of HAP 823 course, Causal Analysis and Comparative Effectiveness. So today I'll be presenting on the topic do operations. Let's have a look at the question. This problem is based on example 1.2.1 in the Causal Inferences in Statistics a Premier book. The following table gives the recovery rates of 700 patients who were prescribed a drug, half of whom took the medication. So we will use this data to answer the questions about the probabilities and the impact of medication. So the table here on the left provides the number of patients who recovered out of the total number of patients in each group. The groups are men and women, and the ones who took medication versus the ones who did not take any medication. Let's move on to the next slide. So part A of the question, what is the probability of taking medications given that the person is a female? So here we find the probability of a person taking medication given they are a female. So women who took medication from the table shows the number as 263. The total number of women would be the ones who took medication plus the ones who did not take medication, which is a very simple calculation, which comes up to 343 in total. So now the probability of female taking medication would be the total number of female taking medication upon the total number of women, which turns out to be 76.7%, which is our answer. On the right side below, there is a screenshot of the Python code output, which also shows us the same result. So this slide here shows us the output for question A. So first a dictionary is created with all the given data. Next, the line 11th and 12th uses the rate function to calculate the proportion, that is numerator upon denominator. Line 15 takes the data where women who took medication, which turns out to be 263. Line 16 counts the total number of women, which totals up to 343. And line 17 calculates the rate, which turns out to be 76.7%. Moving on to the next question, that is part B. What is the probability of remission of symptoms given that the person has taken their medications and the patient is a female? So here we need to find the probability of female patients having remission symptoms given that they took the medication. So we do this by dividing the number of women who recovered after taking the medication, so from the table, which turns out to be 192, by the total number of women who took medication, which is 263. When calculated, turns out to be 73.0%. So the probability of remission of symptoms given that the person has taken the medication and is a female is 73.0%. On the right side, we have a Python code output. So this is the code for part B of the question. Here the line number 20 takes the recovered count of women who took the medication, and line 21 calculates the rate of women who recovered, which turns out to be 73.0%. Moving on to the next question. Which variable is leading to a selection bias? If we had observational data on these three variables and wanted to measure the impact of taking the medication. So here we are asked to identify the variable causing the selection bias in measuring the impact of medication. So gender is a co-founder as it influences both whether a person took medication and also their recovery outcome. As we can see from the data, a high number of women took medication, but at the same time, their recovery is quite low as compared to the men. Uh, so, this clearly explains the imbalance, which can create a misleading association if the gender is not accounted for. Let's have a look at the part D of question. What is the impact of taking the medication? So, taking medication does have an impact on every individual, whether a man or a woman, and even when combined, the data says otherwise. So, gender plays a role as it affects the result of taking the medication and also has an effect on the recovery. So, in our case, both whether taking medication and the gender, they influence the recovery rate. So, any analysis confined to the patients who recovered or those who did not recover would induce an association between the ones taking medication and gender, which may bias the estimate of causal effect of medication on recovery. So, let's have a look at the calculations for men and women according to the recovery. So, men who recovered when on medication will be equal to the men who recovered upon the total number of men taking the medication, which turns out to be 93.1%. Next is recovery of men who were not on medication, which will be equal to the men who recovered upon the men who did not take any medication, which totals up to 86.7%. Let's have a look at the calculations for women who recovered. So, women who recovered and were on medication will be equal to women who recovered upon the women taking medication, which is 73%, and the women who recovered but were not on medication is equal to the women who recovered upon the women who did not take any medication, which turns out to be 68.8%. On the right side, we have a Python code output which gives us the same result. So this is the Python code for part D. So the results, create an empty dictionary to store the results. The for loop checks over the men and women. So line 26 part looks up for the counts, that is gender and medication. So this will give a tuple which with the counts recovered with medication and the total number who took the medication for that gender. The recovered underscore med and the total underscore med stores the results respectively for these two. The line 29 of code counts the rate for the same, and line 31 counts the number of people with medication. This is a screenshot of the Python code, and this part of the code totals the number of men and women count to get the total number irrespective of the gender. So it does not take gender into consideration. Then it calculates the aggregate recovery rate, which is an example of Simpson's paradox. So here the results say otherwise, that the recovery rate with people on medication is lower and the recovery rate of people without medication is higher, which cannot be true. I hope everyone understood. Thank you so much.